Hello, good evening, and welcome to the Cutting Edge stage. This is CogX 2020. My name is Anushka Sharma, and I'm delighted to have taken you through today's proceedings here on the Cutting Edge stage. It's been an amazing day, and this is our final session. Where did the time go? I'm really excited to introduce the next session, but don't forget to join on Slido and on the platform and start getting your questions ready, because the panel will be meeting for a breakout Q&A session after this session finishes, after a short break at 7 p.m. So this is the Cutting Edge stage. This is where you find out about bleeding technology that's research-led, that is being worked on over sort of like the next 12 to 18 months, and it's something for you to factor into your strategy over the next 5 to 10 years. So I'm going to hand over and introduce to the wonderful Zoe Webster, who is from Innovate UK, who is going to be chairing this next session. Zoe, welcome back to the Cutting Edge stage.
Good afternoon or evening. So here we're going to be talking about generalized AI and the next decade in AI. Sounds like the holy grail, isn't it, to be able to take learning from one context or problem to another one. And people are starting to do just that in many contexts, and the work continues. And hopefully we'll hear from our stellar lineup a lot more about what's going on at that bleeding edge. We're going to hear from three panelists, and I'll introduce the second and third shortly. But first of all, we're going to hear from Anima Anandkumar, who is a Bren professor at Caltech and director of machine learning research at Nvidia. She was previously a principal scientist at Amazon Web Services. She's received several honours, such as the Alfred P. Sloan Fellowship, NCF Career Award, Young Investigator Awards from Department of Defence. She is passionate about designing principled AI algorithms and applying them in interdisciplinary applications. Her research focus is on unsupervised AI, optimization, and tensor methods. So pleased to welcome Anima to the stage.
Thanks a lot, Zoe, and it's great to be here. I know this is later in the evening there in the UK, so thank you for sticking around, and welcome to my talk. So I hope you can now see my slides. So what I'm going to talk today is about where we are heading next with AI, right? The past decade has been amazing to me as an AI researcher. There's been so much progress, so much excitement about AI. So the question is, are we done? If not, where do we head next? What are the challenges that are yet to be resolved? And how do we get towards solving them? So when I think about what has led to the deep learning revolution, to me, it's what I call, excuse me, give me a second, sorry. To me, what I call the trinity of AI, right? It's not just what algorithms go into AI, it's also the data and the compute infrastructure coming all together in a synergistic manner. Deep learning revolution started with the creation of ImageNet. Thanks to Fei Li, who's professor at Stanford, for the first time, we had this large collection of labeled data that was available openly for everybody to experiment on. And once this data set became available, that's when we could realize the power and capacity of neural networks, or deep neural networks with many layers of computation. With the availability of large-scale labeled data, you could now train these large models to a high degree of accuracy. But there was a third facet that was also really crucial, and that was the compute infrastructure. In particular, NVIDIA GPUs enabled us to do this large-scale training, to be able to do lots of operations in parallel and be able to train very large-scale models. And all these three are essential to enable the deep learning revolution. And that's why I'd like to call this the trinity of AI, the data, the algorithms, and the compute infrastructure. And since the ImageNet challenge, there have been a number of impressive breakthroughs and progress of AI. But then there are also lots of settings where AI has not lived up to its hype. And that's what I'd like to focus on. What are the gaps that are there today, and how do we fix them? I think a glaring one that you'll see is when it comes to application in safety critical settings, such as self-driving. There's been a lot of hype and excitement around it, but very little progress that actually brings them onto the road in real life conditions. And the reason is because there is a long tail, right? There are just so many possible scenarios that you can't just learn all this in a data-driven manner. That is, you cannot just feed in data or examples of every scenario. You need to build something more into these deep learning AI. Another example of where AI has still fallen short is language understanding. There has been a lot of excitement over the last few years on large-scale language models. These models are able to now generate coherent sentences and paragraphs, but on the other hand, they're still a poor substitute when it comes to humans, right? If you ask them to check content like misinformation about COVID or hate speech, it's still much harder because there's so many nuances that AI does not get when it comes to language understanding. And hence, we have to think about other ingredients to build into AI that can help us really make an impact in such difficult and challenging applications. How do we get there? So for that, I'd like to peek into what are the ingredients of an AI algorithm and how is deep learning dealing with these ingredients, right? So, and especially these are important if we have to build intelligent robots. We have impressive robots like the Boston Dynamics Atlas robot that can do the backflips, but on the other hand, it's still far off when it comes to intelligence compared to our favorite animal. Even when the dog fumbles, it's able to learn new skills, it's able to interact with us, it's able to adapt. And our current robots are not able to do that. And hence, it's important to ask how to bring the mind and the body together, what I call embodied AI. And for this embodied AI, sorry, that was supposed to come together, the mind and the body coming together, what we need is to be instinctive. Humans have instinct, right? So we have priors. How do we build that into AI algorithms? They need to be deliberative, making and adaptive plans. We don't always stick with our plan, we adapt. And being able to function in a multi-agent environment, being able to understand what the other robots are doing, what the other humans are doing. That's so critical. And finally, being able to understand us and partner with us, like what dogs are able to do, we are not even able to build a fraction of that in our current robots. And these are some critical aspects to be built into embodied AI. And to do that, I'd like to emphasize on the algorithms, right? Because that's the foundations, and we need to ask, how do we fix the foundations in deep learning? And for that, the first ingredient is the data. What kind of data goes into an algorithm? And currently, when you think about deep learning algorithms, they are mostly extremely data hungry, meaning they require large data sets with supervised or labeled information. And to do this, you need humans to go and label them, and this is extremely expensive. Think about labeling images, text, speech. All this is untenable when it comes to doing this on billions or trillions of examples. And we need to get away from supervised learning. So I think that's the first ingredient to fix. On the second facet, we have the priors. The priors are additional domain knowledge you build into your algorithm. For instance, if we are operating on images, we typically use convolutional neural networks because convolution builds in translation invariance. And that's good to detect image features. But then these are still fairly weak priors, right? Meaning, if you're now doing any changes to deviate from the training data in a big way, or even in a seemingly small way, you have AI getting easily fooled. There are many examples of this. For instance, a simple way to fool AI algorithm is to add these additional boxes to an image, and it can completely misunderstand what the sign is saying. And given this brittleness, we have to ask, how do we build better neural network architectures and better ways to train these algorithms to overcome these kind of brittle behavior from our algorithms? And so then we have the third facet, which is the task. The task is what we specify the algorithm should be working on, right? So what should it be optimizing on? Should it optimize to get the correct understanding of the image? Should it understand the text? How do we give it an objective function? And finally, if it's an interactive algorithm, how does it take an action and interact with the environment? And right now, if you think about standard AI algorithms, the task specification is extremely simple. We usually have some fixed data set, right? So like the ImageNet, and a fixed challenge, optimize for accuracy on this data set. The problem of doing this is the real world can be very different from this contrived benchmark, right? It may not incorporate everything that's going to happen in the real world. And that's why self-driving is so difficult, because you cannot possibly incorporate all the scenarios in your training data. And there can also be other bad outcomes by training on limited benchmarks. For instance, face recognition has been in the news as being problematic for so many social implications. And this is because the training data and the benchmarks that are available heavily skew towards pale skin tone and the male population. And what happens is, if you're now using this in the real world, especially in sensitive scenarios like law enforcement, this can be a huge problem. We now have protests all around the country, in fact, all around the world, and Black Lives Matter is an important consideration. And you can see that AI building up biases that we see in the society and further amplifying this is a huge problem. And it stems from the aspect of having limited benchmarks that do not represent all populations equally well. And we have many cloud APIs that are publicly available that have very poor performance on minorities. For instance, in this example, Oprah Winfrey was misgendered by this cloud application. And so there is an immense need to move beyond just limited benchmarks and skewed benchmarks that don't represent the end application and the real world needs that are very important. So now what I've told you is these shortcomings that our current deep learning algorithms have. So the natural question is, how do we move from here, right? Where do we go next? And how do we fix these gaps? For each of these three facets, what can we do better? And that's where I'd like to first start with data. It always starts with data, and being able to come up with algorithms that can do unsupervised learning becomes very critical. We do a lot of unsupervised learning. In fact, infants primarily do unsupervised learning after they're born and pick up representations of the world, and then supervision comes in much later. And so how do we incorporate the aspects of being able to learn new concepts, reason about them, disentangle different variations, and be able to extrapolate to entirely new scenarios that were never provided in training data? And I think unsupervised learning is the next revolution, and that's already underway. So when it comes to priors, we need to build more robust priors, right? So for instance, we don't need to invent Newton's laws of motion all from scratch from training data. We can give it as domain knowledge to our algorithm. So in control applications, it's very important to have some aspects that are known to be embedded in the algorithm and only the rest to be learned. And these are frameworks we are pursuing and asking, how do we just incorporate data-driven approaches on parts that are unknown, but still let it function in the overall ecosystem of models and controls. And so you want to have not just one monolithic big neural network doing everything, but you have modules, and each module has different functionalities, and they have to work with one another well. And lastly, when it comes to task specification, moving away from just fixed benchmarks and one task. Can we do a variety of tasks? We call this meta learning or meta reinforcement learning. Can we be adaptive? That is, we don't just do some fixed task, we continue to learn. We humans are lifelong learners. How can we put that into our AI algorithms? So I think these are some critical ingredients to take us to the next level. Focus on unsupervised learning, make our models and algorithms more robust, incorporate domain knowledge, and be adaptive. So these, I would say, are the main takeaways that I'd like you to have from this talk. So I just want to give you one instance of how we can further get inspired from our own brains and from our own perception and cognitive systems. Human brains are so amazing, right? So there's so much flexibility we can have in terms of what we learn, how we reason, how we process, and how we do all this in real time. So human vision, if you think about it, is able to tell even what's in blurry images. If you input even a blurry cat, I can tell you, I think this is a cat. So why is this happening? And what we see is in the brain, what we have is internal models of what a cat looks like, right? And we use that to progressively de-blur this blurred out image and think it is a cat. So just as we are seeing this blurred cat in our brain, we have the feed forward and the feedback mechanisms that continuously iterate over and come to the decision, I think it's likely a cat. And how can we build this kind of mechanism into our neural network algorithms? Currently, they don't have that, right? If it's a neural network, you just have feed forward results by going through many layers, and that's it. Whereas human vision has feedback mechanisms. And in addition to that, it has priors, right? So we have internal model of what the cat looks like. And there are many theories that say our brain is Bayesian, meaning it's going to take in the additional external input from the environment, like this image. It's going to use its own priors, and at the end of the day, come up with a likely answer of what's in the image, right? So that's what perception is about. So can we be inspired by this and build similar mechanisms into our own neural networks, into the artificial neural networks? And to do this, what we set out to do is to unify the paradigms of classification and generation, right? So if I can classify that what's in the image is a cat, I should also be able to generate that this is a cat, right? So that's when you have an example of a cat that is a good example of what it looks like. So by that, what I mean is you want to have the classifier and the generator come together in one model. And they iteratively inform each other, right? So you should have consistency between the classifier and the generator. And that's what our model gives. What it does is it takes any feed-forward neural network, like the convolutional neural network, and it builds a feedback mechanism of trying to generate the image back from the label. And it does this in an iterative fashion, and then in the end, you come up with a result that is consistent. So meaning the generation and the prediction are forced to be consistent with one another. And we see that in some simple examples. For instance, you can corrupt the images in so many different ways here, right? And these were never seen during training data. And that's important to emphasize, because if these are degradations that are not available during training time, a standard neural network would just completely fail. It would have very poor accuracy. But what our model is able to do is to denoise this using the generative model and come up with better classification of what are these digits. And that's important. And that's what we see, the ability to be able to understand what's in the image and hence classify based on that. So that was an example of what is possible by building better foundations and getting inspired from our own brain. Another example I'd like to quickly show is being able to have synthetic data using physically valid simulations. Because if it comes to robotics and to build embodied AI, we cannot just keep generating data in the real world, right? That's too slow and expensive. And what Nvidia Isaac enables is a platform for robot learning by adding in simulated data. For instance, at the Nvidia Robotics Lab in Seattle, the goal is to build a kitchen robot that can do a whole variety of tasks. Open and close drawers, pick objects, place them, manipulate them. All these seemingly trivial tasks for us, but really hard for the robot to adapt to so many requirements. And what we do is to ask, now we can generate a whole range of different drawers and handles in simulations. And hence, we can train this at scale on NVIDIA GPUs in parallel. And if we then do all this together, we can ask how to bring that to the real world. And we are working on efficient domain adaptation algorithms that enable this transfer. So this is another example of how to get rid of dependency on real label data and instead augment that with simulated data that still have physical validity. So to conclude, I'd like to emphasize that the next revolution in AI requires generalization, and generalization beyond just the training data to entirely new scenarios that were unseen during training. And the key aspect that will enable this is unsupervised learning. We humans do a lot of unsupervised learning, and in our brain we have feedback mechanisms that enable the ability to incorporate prior knowledge about the world. And we need to bring that into our AI systems. And in addition, we need to also look at how large-scale AI frameworks will enable us to take these algorithms to fruition and to the real-world applications. Thanks a lot.
Thank you so much, Anima. That was fascinating and good to see all the work that you're doing. I personally have a background in symbolic machine learning, so it's fascinating to see what's going on here. And perhaps we can come to a discussion about hybrid models a bit later. So I'd like to introduce our next two panelists who have got amazing backgrounds and will contribute so much to the discussion. First of all, we've got Maya Pindeus, who is the CEO and co-founder of Humanising Autonomy, a company using deep machine learning to become the standard for communication between autonomous systems and people. Welcome, Maya. And also Dr. Lisha Li, who's the founder and CEO of Rosebud AI, a tech company that uses deep learning to create visuals of models for marketing that look indistinguishable from human models. She was previously a principal at Amplified Partners, leading investments in early stage startups, and worked in data science at Pinterest and Stitch Fix. Welcome, Lisha, as well. So I'd like to invite you both, Maya first and Lisha, to just give a bit more about your perspectives before we go into a panel discussion. So please, Maya, take the floor.
Sure. Thank you very much. I'd like to talk a bit more about one of the biggest technology challenges today of developing an AI system that is able to work across multiple physical environments, to operate around all stakeholders, people, understand their behaviors and actions, and all of that without creating mass complexities, and by making sure that systems are designed with the human experience at the core. When looking at urban mobility, a spectrum where software-enabled vehicles and systems interact with people at all times, it becomes crucial to rethink how we approach automation and think of human behavior as this universal design principle behind our automated systems. It fuels our automated systems to teach machines how to read our visual signals, how to understand these signals, how to understand these behaviors across various environments. Humanising Autonomy is a predictive AI company creating a global standard that improves the way vehicles and systems interact with people in any environment across multiple markets. Our mission is to ensure that automated systems evolve around human values and not the other way around. What this means is that we offer a horizontal, vision-based solution that captures the full range of human behaviors into a predictive system that provides real-time behavior predictions available on the edge and in the cloud, which are ideal for immediate human-machine market applications, particularly in the urban mobility context, thinking of urban infrastructure, dash cams, driver assist systems, but are also optimized for long-term autonomous system development. Our AI is based on a unique combination of behavioral psychology, statistical AI, and novel deep learning algorithms to create a multidisciplinary approach. This allows us to extract observable and inferable behaviors from video data, from vision data for intent predictions and predict the multitude of people's behaviors on the edge. We are modular. We're based on modules, software models to work together to generate fast and accurate predictions. And we're fast and flexible, meaning hardware agnostic solutions that has a small programming footprint and is applicable in real time and able to integrate across solutions today and solutions for tomorrow. Those approaches, the modularity, hardware agnostic, and the behavioral psychology approach allows us to capture this complexity of human behavior. And really, it is about enabling machines to operate around people. In an urban mobility scenario, that means 4 things, really. Increasing safety, improving decision-making, faster and more efficient progress, providing a better and smoother customer experience, and enhancing sustainability. To give a couple of examples, by allowing a vehicle to have better hazard perception, or a driver to have aided in hazard perception, we are able to reduce accidents, reduce collisions, accidents, near misses involving people, vulnerable road users. Through better decision-making, we're able to improve progress and improve the driving efficiency by a multiple. Making journeys smoother, reducing hard braking event, allowing the vehicle to really understand what is happening around the scene when driving, let's say, through central London, when driving through a crowded, pedestrianized environment, and really understanding what people are about to do. Are they standing? Are they about to cross the street? Are they distracted? Are they alert? Many, many things. Ultimately, enhancing sustainability by allowing the vehicle to be more efficient, to have better decision-making, we reduce hard braking event, increase fuel efficiency. What's important is building a system that is applicable today through this hardware-agnostic approach, a small processing footprint with plug-and-play integration with various applications. Like a device helping, in the urban mobility context, a device manufacturer to deliver dashcam CCTV systems to increase fleet, passenger, pedestrian safety, help vehicle manufacturers to deliver safer, more innovative driver experiences that are also scalable to autonomous vehicles, help insurers rely on reduced risk models, and help vehicles adapt to people, and municipalities to understand behavior patterns so that cities can be planned around the citizens and not vehicles. And it's really about powering automated technology that is always able to not just look at people, understand people's actions, and determine what the best action will be to keep them safe and to keep the interaction pleasant. By doing it visually, we have adopted an ethical approach. It's important to be transparent. We're modular, which allows transparency, with a strong emphasis on personal privacy, keeping persons' data safe and well, and never track, trace, or identifies everyone. By being modular and horizontal, being able to apply this AI application to existing vehicles and systems to really help improve urban infrastructures today. We're a team of 30, multidisciplinary team of deep learning engineers, psychologists, roboticists, and commercial talent, based in London and Tokyo, and working across 3 continents. And we all came together to really build this global standard for human-machine interactions. Thank you very much.
Thank you so much, Maya. And Lisha, we'll pick up on some of the comments that Maya just made, but Lisha, if you'd like to give your perspective.
Wonderful. Thank you for having me. And Anima, I mean, thank you for painting the framework of what we can be excited about and what we should look into improving for the next kind of decade of generalized AI. To give color to one of these, which is unsupervised learning, in the area that I focus on, which is generating visuals and creative content in general, I just kind of like flesh out where I anticipate the exciting developments are and what kind of motivated me to start Rosebud. I mean, the last couple of years, we've observed such tremendous advances in quality of visuals that we can generate. In particular, for instance, one of the open source things that was put out by Nvidia with StyleGAN generating faces. I mean, I think people in the audience might have already seen in the news really high quality headshots of a person that doesn't exist, right? And so when I saw the advancements of these results, I think there's a couple of things that was very exciting. I mean, one, the quality is getting to the point where it's high enough for commercial application, but two, to just take things straight from the research lab into application, there's kind of a lot of difficulties in making it work. First of all, you're never sort of talking to customers, so you don't know exactly how to define certain type of technical problems to give customers the amount of control that they want. So especially in an area of like, creative output, it's a very intimate kind of relationship with like, who's your user? Well, is it the designer? Is it a marketer? Is it somebody who's creating entertainment content? They want a certain degree of control. And the kind of process that you're augmenting and somewhat making more efficient is like they're back and forth with agencies, or even the agencies work with photographers and models. And so I knew that like what was exciting about this problem is that you cannot possibly only do it in isolation in a research lab. You need to help you need to help inform the technical problem from working with customers. And then in particular, in the case of generative models and models that are supposed to reproduce, distributions of like really rich inputs, such as images, there is no canonical measure of what's good, right? So in the case of, say, generative adversarial networks, you have this like game between the generator and the discriminator to sort of get better at reproducing images from people's faces, or whatever. Choose your favorite domain. In that case, because we don't have a canonical measure of what's good, it becomes even more crucial to put it in the hands of users to help you define like what does it even mean to have good quality. So in the case of Rosebud, for instance, my vision is that I think that this in the 5-year, 10-year time, a lot of our creative processes will be augmented, if not, completely, made like democratized by AI. And what I mean by democratized is really like you've elevated everyone, brands, people who need to create visuals, to the level of a creative director. They will have access to this like software in order to produce exactly what they're imagining in their head. But in order to get there, you have to start solving concrete problems. Now you have to get into the workflows and really respect both how things are done and figure out what are the low-hanging fruit to get the data input and output that actually solves people's problems. So I think one of the other topics I'm really excited to touch on is like, it doesn't have to be this black-white picture of like replacing people versus, like don't use AI, don't replace jobs. It's much more about augmenting human creativity. And that's kind of what inspires me about this area of research, and what inspires me to productize it, because I really see it as like augmenting people's ability to creatively express themselves. So even if like the first application is, say, marketing visuals, it's about like figuring out what are the sources of pain or friction, right? So right now we have the entire world is kind of suffering through like sheltering in place and not being able to have physical processes such as photo shoots. So it's a prime time to be moving and migrating to a generative process where most people can now do things with software. In my case, I'm generating novel models, like human models, and getting it to look like the demographic that people care about or represent a particular brand aesthetic. And through figuring out these problems, I can then input the technical improve the technical capabilities of these deep learning models to kind of express towards what these customers want. So kind of very excited to dive deeper into these categories. Oh, and if people wanted to check out what some of these visuals actually look like, go to rosebud.ai. So you'll have plenty of visuals to sort through and exactly what I mean by indistinguishable from human.
That's fantastic. Thank you so much, Lisha. Just great speeches from you all, and lots to think about and lots to crunch through. And I know there'll be lots of questions posed by the audience, and we'll come to those a bit later. In terms of the questions that came up for me, a couple of kind of themes come up. Is one around that AI trinity that you mentioned first up, Anima, and it struck me that a lot of people do focus on the data and the compute and the algorithms, but not everyone thinks so hard about the users or the customers or the people behind that. So I guess the general question for me is, do you think we can make the progress we want to make? And in the next 10, 20, 30 years, if we don't have everyone embedding the kind of the user within their design, the development of AI going forward. I'd like to get your thoughts on that. Maybe we start with you, Anima.
Yeah, I think you bring up a really important point, right? So democratization of AI is really critical to me, and that comes in so many ways, right? It starts with representation of all populations and demographics in our data sets, and I did bring that up in my talk, that data imbalance is a critical problem, especially if you're now launching this in the real world in socially sensitive contexts like law enforcement. And so we need to be mindful of representing the data well and having good benchmarks. I think that's the start. But another important aspect is having diversity in the AI workforce, right? So if you look at the representation of AI researchers, it's extremely skewed. I mean, there are a lot of amazing female AI researchers, and we have affinity groups like Black in AI, Latinx in AI, queer in AI, but we don't see them always represented in the same light, in the mainstream media. And that's something I emphasize a lot on, to bring more diverse thoughts into AI, and that's how we can grow and put that to the next level. In fact, the gender state study that brought up the issue of face recognition being biased against minorities was by a Black researcher in MIT. So we have to have this diversity in our schools, in our AI companies, and that's something we should strive for. And finally, I think indeed, even if it's not AI experts, right, everybody else who uses these AI systems and the interfaces, we have to ensure that we take their input. For instance, if Alexa works only on certain accents and does not recognize my mom to the same extent it recognizes me, it's a big problem. Right? So we have to ensure that there is good quality of service available to everyone and their inputs are taken.
Absolutely. Thank you, Maya. Lisha. Maya, perhaps you first?
Sure, yeah. I think it also comes to really take into account a multitude of environments. When I think of the area we operate in, where we work in cities, automated system operating through dense urban environments, to make sure that data sets are collected from a representation of the real world, meaning not only Silicon Valley, but European, Asian, African cities, where to be able to really take this kind of whole multitudes and actively create this equal representation, but also take into account edge cases, take into account different things that people do and people's actions, make sure that those are also included in data sets. And if during training we're recognizing that more needs to be included, more needs to be added, be transparent as well, and kind of recognize where the system requires more data and more of these peculiar situations.
That's really helpful. Thank you. Lisha, did you have perspective on this?
Yeah, when you guys were talking about it, what came to mind is a specific example on how basically when people sort of think about, okay, if you can create faces, like what, maybe that obviously just perpetuates very unrealistic beauty standards. And what's interesting to me about that response is actually, this is why it's so important that, I kind of sit in the front seat in helping productize and develop tech in this area. Because really, if my users are very diverse, that actually helps, and I make the tool that more allows more people to create visuals. I've actually introduced more diversity in the voices of like what are beauty standards there. So actually a bunch of my users are Gen Z, say fashion designers, and they have very non-standard beauty sort of like aesthetics that they want to represent with their brands, and that's kind of what I'm excited in seeding. So yes, of course, if you have standard, very classical beauty standards, you can express this with a tool as well. But it's really in like how you're trying to motivate and distribute this platform and expressive tool.
Thank you. That's really helpful, and I'm sure there'll be a lot more questions on this. I think we've got 5 minutes left, and one of the questions I wanted to ask was kind of on the technical side as well. I mean, you mentioned kind of the push towards unsupervised learning. I think for me that raises questions around explainability. Is that important? Is that helped or hindered by going further down that route? And also that you mentioned the Bayesian approach. I wondered whether you see there's room for hybrid approaches, because I think from what you're saying, deep learning does have limitations, but again, that's where a lot of the focus is and has been for a number of years. Do you see the possibility or the need to even look at other approaches, or to kind of develop hybrid approaches at any of this? Or do you think actually a lot of the tasks we want to look at, deep learning is going to be the way to go?
Yeah, that's a great question, right? And to me, as a researcher, I'm always curious to understand different aspects and different approaches, and also ask how they can work together, right? Because I think the answer in the end will be some kind of hybrid systems. Deep learning is great when it comes to learning in a non-parametric way with lots of data available, right? You can have now a flexible model. You don't have to make a lot of assumptions, and complex data like images, you can extract the features. So that part is important. But when it comes to, let's say, explainability, you say that you've uncovered a concept called the chair, right? Then you should be able to generalize to new chairs that you didn't see in training data, but still there is a concept called chair. And there I think we'll have like neurosymbolic systems, which are hybrid. So AI classically was all symbolic, right? It was based on logic. How do you kind of operate on different concepts, right? What kind of inference do you make? And so I think some of that is coming back, and the question is, how do you scale that and put that in conjunction with deep learning? And I think that also enables us to provide us with modularity. So it's not one monolithic big neural network, but you have parts, and each part has its functionality, and it can talk to one another. Just as we don't build a huge aircraft all from scratch, end to end with data, we have to build parts, and we have to make sure that each part is well tested and put together. And that's where I think neurosymbolic systems will play a role. I think with Bayesian inference, there are interesting questions of how to bring in prior knowledge, right? And that's what I emphasized in my talk, that Brain has all these internal models. Can we also bring that frameworks into our deep learning systems, and and of course combine it with also data-driven training, right? So it's not, I think there won't be one answer, it'll be a combination of answers.
That's great. I guess the final question I'd like to pose in kind of closing minute or two, I guess maybe us for 20-30 seconds from each of you, is around how it's best to engage the public, the users, the customers, given all the change that's likely to happen in the next 10-20 years. What is it that the AI community should be doing to communicate the art of the possible, and what might be coming up to people outside the community? I don't know if you've got any thoughts on that. Perhaps, Lisha, we could start with you.
Yeah, sure. I mean, especially in the area that I'm working in, there's a lot of very obvious negative use cases. I mean, deep fake and propaganda is like the first ones that come to mind. We have a code of ethics that kind of, we started it early on because it was really important for us in a position of knowledge to just make it clear that we're going to share our understanding of where the tech is going and kind of make it a responsibility to educate the public. And I think that's for anybody who's like working in the area from a research perspective or a product perspective, that's the first thing that they can do. And especially especially since given how kind of democratized this platforms of sharing, we're not sort of like only beholden to the media in order to communicate one-on-one. That's where we've at least been able to take action. So yeah, just kind of sharing like what are the capabilities so people know at least what's out there, so nobody's guessing.
That's great. Thank you, Maya. Do you have any thoughts?
Sure, it's great to hear, Lisha, about the code of ethics, and I think ethics is really, one of the most important things to kind of bring out to the public, and how data is treated, how AI can be, explainable, how it can be transparent, how it's not all about data-driven end-to-end systems, but I think the modularity comes into play. But also thinking about user experience, and user experience not just as the person who purchases a service or device or whatever it may be, but the public as a user, really, because that's what happens with AI. Really, we all become users, and if we all, AI is designed with us people in the loop. And I think step-by-step introductions to automated systems and really educating the public around what this means and the opportunities that this become. I think that will be, helpful steps.
That's great. Thank you. Anyway, have you got any final comments on how we can best engage to make sure that we adopt in the right way?
Yeah, I think as AI scientists, we have a responsibility to give honest and balanced feedback on the different systems that are are getting popular, right? And especially with deep learning. So I have called out in the past when I think it's hyped up and not realistic, especially with language understanding models that that are impressive but still far from replacing humans. And also tackling misinformation around AI, I think, is critical. The Sophia, I call it the fake bot, because it's almost a dystopian world we are in, where there are no female speakers represented in some of the conferences, and then we have the Sophia front and center, right? And it even appeared on the Cosmopolitan magazine. I mean, no female AI researchers has ever appeared on that magazine, and so we have a huge problem there when we have feminized bots being represented, whether it's Sophia, whether it's all the voice assistants, and instead we have bad representation when it comes to AI researchers. I think we need to fix that.
I think that's a great point to end on. So thank you so much. Thank you to Anima, to Lisha, and to Maya. Fantastic contributions. Lots to think about. I'm sure we'll get lots of questions to answer after the break. At this point, I'd like to hand back to Anushka.
Thank you. Thank you so much, Zoe. What a fantastic conversation. And for anyone who's watching, you can click through from 7 p.m. to the Q&A session. Make sure you get your questions into the panel. There was so much to cover. I mean, generalized AI in the next decade. In AI, there is still so much to do. So we'd love your questions to come through. This is the cutting edge stage. My name is Anushka. I've been your host since the morning, since 10 a.m. We've taken you through all of the proceedings today. Today, we've covered everything from giving AI a human face to implementing how to implement AI as a smart co-worker. And we've looked at and dived into the interplay of AI and the collective intelligence. We've discussed collaboration across research and community with Facebook AI. One of my particular favorites, and I can't be biased because every session has been fantastic, was the conversation and panel on empathetic AI. And to round off with sort of like the next decade in AI has been full of lots of insights that we have yet to build on. And yet, this is only day one of a 3-day festival. For the first time in its 4-year history, CogX has gone completely virtual in light of the current pandemic. So there are 2 more full days of content here on the cutting edge stage. So I'm going to wrap up formal proceedings of content here on the cutting edge stage. We'll be back live tomorrow from 10 a.m. My colleague Gemma Milne will be taking over. I will be chairing a panel on the planet stage, and we'll be looking at space data And I look forward to welcoming you to the programming on the Planet stage tomorrow. So this is me, Nush, signing off from the Cutting Edge stage today. Thank you for joining us. Keep the conversation flowing on Twitter with that hashtag CogX2020. And if you'd like to follow the links through to the breakout room, please continue the conversation with questions for our panelists from our last session. Thank you so much.
Want access to more CogX videos? Subscribe now for free at cogx.co.